All right, guys, today we're going to go ahead and start doing our day 2 notes here for graphing sine and cosine. All right, so we've got this little warm-up right here. I hope you went ahead and took some time to go ahead and try this on your own. If you did not, go ahead and pause the video and do so. But here we have, it tells us to graph two periods of the sine function and label the axis and determine the indicated information. So the indicated information is all down here. So I'm going to go ahead and graph my sine function. We should recall that sine does this up, down, up movement, whereas cosine does this. Way that I usually suggest for people to try and remember it, and I mean, it's not perfect because you can kind of see a bit of an S with this one, and you can kind of see a bit of a C with this one. So like you have a little bit of an S shape right here and a little bit of a C shape, like if you were to turn it. Obviously, this isn't truly an S, it's kind of backwards, kind of, and then this one is not on its side, but kind of pointing up. But that's kind of the way that I try and tell people to try and remember it, so that if you're trying to remember between the two of them, you can do that. So for sine, that means this one's going to go up, down, up. And then I have to do 2 periods. So yesterday we had the exact same x-axis and y-axis, and I did the whole thing as 0 to 2 pi. So now I'm going to do the exact same thing, or the same x-axis, but not the same distance here. We're going to do 2 periods. So what I'm going to do is I'm going to go, okay, so if this is 1, 2, 3, 4, 5, 6, 7, 8 sections that I'm going to use. And what I could go ahead and do is just call this one pi over 2. This one would be pi, 3 pi over 2, and then 2 pi. So there's my unit circle going along my axes. Now, since I have to do 2 periods, I'm going to go ahead and continue that. And so if this is 2 pi, I know I'm going to end up with 4 pi down here, but I'm going to just keep on going. So if I go 1 half, 2 halves, 3 halves, 4 halves, 5 halves, so 6 halves, so 6 pi over 2, that's 3 pi, and then 7 pi over 2, then 8 pi over 2, which gets me 4 pi. And then just for the sake of it, I'm going to go ahead and just continue a little bit and say 9 pi over 2, but I don't actually need that one. All right, so to do 2 periods, I also have to remember that this is going to be 1 and this is -1. So let me go ahead and put this in as a different color. So sine starts at our midline, the middle of the graph, and then it goes up to 1, back down to 0, back down to -1, and back up to 0. So that's my 1 full cycle right there. And then I'm going to keep going. So then at 5 pi over 2, 5 pi over 2 right here is coterminal with pi over 2. Those are in the exact same place on my unit circle. It's just this is doing a full rotation and then an additional 90 degrees, or pi over 2. So it's going to be in the same location. 3 pi is in the same location as pi. It is coterminal with pi. 7 pi over 2 is coterminal with 3 pi over 2. And 4 pi is coterminal with 2 pi. So I have this graph going kind of like that. I hate how it always deletes that. Okay, so that's what I have for my graph. So that is 2 periods of my sine function. Now let's go ahead and determine all of the indicated information, my domain. So remember, domain is all of your x values. Well, I have nothing that restricts my x values for sine. Everything is defined. So it would be from -infinity to infinity. My range. So can I have all y values on my function? No, I cannot. It doesn't get any less than -1. It doesn't get any greater than 1. So my range is from -1 to 1. My period. So how long does it take before it repeats itself? 2 pi. Intervals of increase. Well, yesterday I did over here -pi over 2 to pi over 2. You could do that as well for your interval of increase, but I'm going to go ahead and change it up a little bit, and I'm going to make it be from 3 pi over 2 to 5 pi over 2, because that also works. So let's try that. So I'm going to do 3 pi over 2 plus 2 pi k to 5 pi over 2 plus 2 pi k. And parentheses. Remember, I need to say where k is an integer. All right, intervals of decrease. So decrease. Where am I decreasing? So I'm decreasing. If I was to put that ball on the top of my graph right there, it would roll down. So it's decreasing right there. And that's going to go ahead and that would be from pi over 2 plus 2 pi k to 3 pi over 2 plus 2 pi k, where k is an integer. Okay, now let's go ahead and take a look at what we have here. All right, several vocabulary words associated with sinusoidal functions. The midline, here, midline, is the horizontal line that splits the wave in half vertically. The amplitude is the height of the wave from the midline. It can also be described as the length of the radius of the circle. All right, so I have this graph right here, and now it says in the above graph, the midline is y equals. So let's go ahead and look. So the midline is going to be this little dashed line that we can see right here. That's what the midline is. So the equation is going to be y equals, and if you notice right here, it's a horizontal line. A horizontal line is always going to be y equals, just like a vertical straight up and down line would be x equals. So it's going to be y equals 1. Okay, and the amplitude. Well, the amplitude is that distance from that midline to the highest point of my graph. So it's this distance right here. So if I go from 1 to 3, that's a distance of 2. Okay, all right. So then the equation for the graph. Well, let's talk about that. We could have a number of equations that we could use for this. There's no one exact equation that it could be. There's really an amount because you could rewrite this a whole bunch of different ways. But what I'm going to do is I'm going to make this as easy as possible. And when you are writing the equations based off of a graph, when you're doing it as easy as possible, you're looking for if you have a maximum, minimum, or a midline point on the y-axis. And I happen to have that right here where I have a maximum point right here at 3. And that tells me if I go ahead and look at what I have here, the reason I want a maximum is because now I can consider my entire graph that I have right here. And what shape is that? That's cosine. So I can go ahead and use that information. Sure enough, I do have a sine graph on here. It's just not readily apparent because it's just cut off just a little bit right here. Otherwise, that would have been a sine function that I could have used right there. I could still use a sine function on here, right here, also here, but I'm not going to. I'm trying to keep this as easy as possible. Work smarter, not harder, right? So I'm going to use the one that's right here where no shifting side to side, anything like that. All it is right here on my y-axis. So I'm going to go ahead and write the equation that I have right here. So I'm going to say this is cosine, right? We know this is cosine. And so then my amplitude. Amplitude is going to be my height right here, and that's the 2. That's your A value. So we talked about that yesterday. And so that's going to be that 2 cosine. Okay, I'm not going to go ahead. I'm not opening up the graph going the opposite way or anything like that. It's not going upside down and going like that. So it's not -2. So it's a +2. So I have 2 cosine x. The only thing that's really changed from that is I've shifted this graph from here as the midline up 1. So I have +1. Because yesterday, your sine graph and what we just did on our warm-up, let's go ahead and scroll up here. Remember, right here, sine started in the center, but my midline was the x-axis. Same thing here. The midline for cosine was the x-axis, and it no longer is that midline right now because it's been shifted up 1. So now let's go ahead and look at what we have here. So to graph an equation, we're going to make a t-chart of critical values, then apply any transformations to the appropriate part of the chart. Amplitude, vertical reflection, and midline all impact the y of the chart. So one thing I'm going to kind of go back to that I've talked about several times before, and I even mentioned it yesterday. So you have a f of b of x minus h plus k. So if I use this format that we have, a, as we mentioned yesterday, that's our amplitude in this, but that's always for all functions when we're talking about transformations and changing them, that a value that's being multiplied out front is always going to be a vertical stretch or compression, right? So that's what we have there. We've already discussed that. Right now, what we're going to discuss is what this k is going to do. Okay, so that's what's being added or subtracted at the end. Whatever I have added or subtracted at the end is my midline. That's your vertical shift. So we have a vertical stretch or compression, and here we have a vertical shift. Okay, so stretch, compression, shift. So if I go ahead and consider what we have here, and again, because it's vertical, it's going to change that y value. All right, so let's look at what we have right here. If I have the equation cosine x plus 2. So first thing that I need to do is I need to go ahead and just fill in what these x values for my table should be. Those are going to be those critical values on the x-axis that we've been using. It's not going to always stay this way, but right now it is because all we're doing is just moving the graph up or down. That's it. So I'm going to have, I shouldn't start at pi over 2. I need to start at 0. So I've got 0, pi over 2, pi, 3 pi over 2, and 2 pi. So I have those values, and I already know at this whole entire thing, what I'm going to go ahead and do here is if I go ahead and plug in, if I just have the y value for cosine x, that's all I'm going to do right here. I'm not even considering this plus 2 right now. I'm just doing cosine x. So if I have cosine of 0 is 1. Cosine of pi over 2, that's going to be 0. Cosine of pi is negative 1. Cosine of 3 pi over 2 is 0. And cosine of 2 pi is also 1. So I have that information. So all I've done is just done the very basics of what a cosine graph is going to do. And now I'm going to apply that transformation. And that transformation right here is say, take those y values, just like it says right here, it's going to impact the y values on the chart. So I'm going to take these y values and I'm going to add 2 to them because all I'm doing is I'm taking this 1, 0, negative 1, 0, and 1, and I'm just moving them up 1. So if I do 1 plus 2, I get 3. If I do 0 plus 2, I get 2. If I do negative 1 plus 2, I get 1. 0 plus 2, again, I'm back at 2. And 1 plus 2, I get 3. So that's where I'm going to go ahead and get all the new values of my graph. And so what I'm going to want to do is I'm going to want to graph these x values, and I'm going to want to graph these y values. The ones in the middle are my old ones. Those are not the new ones. Those are the ones before I've applied the transformation of the plus 2. So now I'm going to go ahead and label my x-axis. And so I'm going to go ahead and say, all right, I got pi over 2, pi, 3 pi over 2, and 2. Okay. And then I need the x-axis. I don't need negative 1 anymore. I just need 1, 2, and 3. So I'm going to go, okay, so 1, 2, 3. Okay, so first thing that I'm going to do that's going to help me in drawing this graph is I'm going to go ahead and draw a dashed line for my midline. So straight through this 2, I'm going to do a horizontal dashed line. Now, how did I know that that's my midline? Again, I already said right here, whatever you have right here at the end, or whatever it's written, it could even be written at the beginning, because I could also rewrite this equation as 2 plus cosine x. It's the same thing. So if it's added, not to the trig function, but like after, like added to, I should say, let me rephrase that. If it's not added within the function, what I mean by is right here. So it's not inside the cosine function. It's outside of it, added or subtracted, that's your midline. Okay, so whatever my k is, that's my midline. And so now I've got that horizontal dashed line right there through 2. And then I'm going to go ahead and just plot these points. I'm going to go ahead and at 0, we're up at 3. At pi over 2, we're at 2. At pi, we're at 1. At 3 pi over 2, we're up at 2. And at 2 pi, we're back up at 3. So we have that going on with our graph. So that is exactly what I just need to graph. I don't need to worry about graphing any more than just one period. I don't need to do 2, 3, 4. It's just one period of my function. That's really all I need to do. Okay, so what's my domain? So in case you haven't figured it out, cosine and sine have a domain always of negative infinity to infinity, unless there's been something really weird done to the function where they say that you know it cannot be something. Other than that, it will always be negative infinity to infinity, or all real numbers. Now my range, however, I do not have a number below 1 and I do not have a number above 3 for my output values. So my range is from 1 to 3. The period of the graph, well, it goes from 0 to 2 pi before it starts to repeat again, so it's 2 pi. The midline, y equals. You must write y equals. You cannot just write 2. That's not what it is. It's y equals 2. That's an equation because this line is an equation, okay? And then my amplitude, that's the distance again from the midline to the highest point. So don't fall for it. Don't fall for the trap and do from the bottom to the top. That's not it. It's half of that. It's half the distance between the maximum and the minimum. So my amplitude in this particular case is just 1. All right, so let's see what we got here in this next one. I have negative 3 sine x minus 1. Okay, so I've got some stuff going on here, and we've kind of combined this into several different steps in a table here. So let's go ahead and see what we have here. All right, so let's go ahead and fill in the x values. Again, because we haven't shifted our graph right or left, and well, not even right or left, but we haven't changed the period of our graph, and that's going to be something we're going to do later. The x values here are going to be just those standard 0, pi over 2, pi, 3 pi over 2, and 2 pi. All right, so then if we're doing sine, okay, so if I just did sine at all of those values, so what is sine of 0? Sine of 0 is 0. Okay, sine of pi over 2 is 1. Sine of pi is 0. Sine of 3 pi over 2 is negative 1. And sine of 2 pi is back at 0. Okay, so those are the values that are on my unit circle. Now let's go ahead and apply the transformations. So we've got 2 transformations here. Well, 3 actually, if you pay attention. I have the negative right in front. So that negative right there is going to be a reflection across my x-axis. So everything that was positive becomes negative. Everything that was negative becomes positive. All right, and then the 3 right here, that's my vertical stretch of 3. So that means it's taking the graph, and instead of going from 0 to 1 to 0 to negative 1 to 0, it means this 1 is going to stretch up to 3, and this negative 1 is going to stretch down to negative 3. So it actually makes my graph taller. So let's go ahead and do exactly that. So that's what this negative 3y is for. It's saying I'm taking this y value, just multiplying it by the negative 3, because that's what that a value is in front. So 0 times negative 3 is still 0. 1 times -3 is -3. This one's still 0. And then this one's going to become 3. And this one's still 0. So you can see what was positive becomes negative, and what was negative becomes positive. All right, now we have one more little part of our table right here. And this part of our table right here, this -3y minus 1, I want to make sure that you don't do too much. So it's not saying that I take everything that's here, multiply it by -3, and then subtract 1. These values here are -3y. So it would be 0 minus 1. So -1, right? Because this 0 is -3y, because that's what we have here. So be careful. Just don't try and do too much all in one. That's all I'm saying. So then here, -3y is -3. And then I'm going to subtract 1 from that. So it's -4. 0 minus 1, -1. 3 minus 1, 2. 0 minus 1, -1. So you see I'm going -1, -4, -1, 2, -1. So let's go ahead and label our x-axis. So that's going to be pi over 2, pi, 3 pi over 2, and 2 pi. So I've got those values, and now I just need to label my y-axis. So if you notice right here, I go all the way down to -4, but I also go up to 2. So I'm going to go, okay, so I got 1, 2. Then I go 1, 2, 3, 4. So here's -4, 3, -2, -1, and 1. I tried to space them evenly so it's going to give me the right kind of shape. So now I'm going to go ahead and draw that midline graph for my graph, okay? That's going to be, oh, I didn't mention. Let me go ahead and mention that here. That's what this one is right here. This is my midline. So remember, my midline is whatever is added or subtracted outside of the trig function. So this is going to be my midline here. So I have this little horizontal line straight through -1. And so I've done this little dashed line through there. And now I'm going to go ahead and graph my function. So I'm going to plot these points. So I'm going to plot 0, -1. So at 0, we're at -1. Oh, sorry, not my little dots there. All right, and then at pi over 2, I'm at -4. So pi over 2, we're down here at -4. At pi, I'm at -1. So at pi, I'm at -1. 3 pi over 2, we're at 2. And 2 pi, we're at -1 again. So I have, ooh. All right, so that's going to be what I have right now. And if you notice, this is different because remember my sine function normally looks like this. And the reason that it looks different is because of that negative in front that reflects it across my x-axis. So let's go ahead and figure out the critical information here. So what is my domain? Again, it's sine or cosine, and either one of them are always going to be -infinity to infinity. My range. So my minimum number here is -4. My maximum number here is 2. So there's my range. -4 to 2. My period. It's 2 pi. It takes 2 pi until it starts to repeat. Midline. Again, y equals -1. Amplitude. Amplitude is that distance between the midline and the highest point, or you can find the distance between the maximum and the minimum and divide by 2. And if I did that, so let's try that. I kind of think I like that because that might be a little bit more universal. That's what you would do. You'd find your maximum, subtract your minimum, and divide by 2. So in this case, 2 minus -4 divided by 2. Well, 2 minus -4 is 6, so 6 over 2, that's going to give me 3. So my amplitude is 3. I can see that if I go ahead and go right here, if I'm at -2 as my highest point, I'm at -1 right here, so I go -1 to 0 to 1 to 2, that's 3. That's my amplitude, okay? All right, so the general form of a sinusoidal function is, and that's exactly what I got here. I will go ahead and admit that this right here, this is actually from our AP Pre-Cal stuff, and The addition sign there is not typical. A lot of it's more universal, I think, to use a minus. Don't ask me why. That's interchangeable. It just is. But we're gonna go ahead and do that. Okay, so what does the A do? The A is a vertical stretch, or compression, right? So it makes the graph taller or shorter. It also can reflect across the x-axis. What does the K do? So this K at the end, again, like I said earlier, that's going to be our vertical shift. It's going to do exactly what you see it do. So if it's +3, you're going to go up 3. If it's -1, you're going to go down 1. So it's not one of those where it's the opposite of what you see. That's on the inside. Remember, on the outside of the function, the transformations are what you see. On the inside of the function, the transformations are the opposite. That's something that you should have learned in advanced algebra. All right, so beyond midline shifts and reflections, amplitude changes, sinusoidal functions can be altered by transformations that affect the horizontal portions of the graph. The transformation that stretches or compresses the horizontal values affects the period. So, very good, of the graph. In the standard form of a sinusoidal function, b is the value that changes the period. So we're going to go ahead and look at that. So we're going to go ahead and determine our period by going, it is always going to be done as 2 pi over whatever b is. So when you're given an equation and you have some value in here for whatever this b value is right here, up in the equation, so either here, notice it's inside the function, okay? You're always going to just do 2 pi divided by whatever this number is, and that tells you what your period is. So let's try that. So if I have this right here, I'm just given sine of 4x. So you see how this 4 is multiplied by the x inside of there? That's how I know that that's going to be that b value, and that's going to affect the period of my function. So the first thing that I'm going to do is I'm going to go period is 2 pi over 4. Well, what is 2 pi divided by 4? That's just pi over 2. So we've taken our period and we've changed that, and it's now going to be pi over 2 for that period. What I'm actually going to do with that information is I'm going to use that in my table, and I'm going to create a table. Notice you're not given one right now. So what I'm going to do is I'm going to go ahead and create one. So say I've got x and I've got y. And I'm just going to go ahead and create the table like I normally would. Instead of this 4 being there, I'm just going to do sine x, okay? And so if I was doing sine x, we'd have 0, pi over 2, pi, 3 pi over 2, and 2 pi, right? That would be all of my x values because that would be my x-axis. My y values for sine at 0 would go 0, 1, 0, -1, 0. Okay, so now I need to take that information and I need to apply the transformations that I have to this. So the easiest way to do this, there's a couple different ways, but I think this is going to be the easiest way for most people, is I need to remember that right here, anything on the inside of the function changes x values. Anything on the outside of my function, so that a and that k, are going to change my y values. Okay? That's really important to remember if you're going to do this little table idea. And truly, I think the table idea is the best thing to help you guys. It's been something that truly has helped a lot of my students in the past. So I'm going to go ahead and I'm going to take my table And I'm extending over here on the left because I'm going to change these x values because this 4 is on the inside, and so that's going to affect my x values. Now remember, everything that you see on the inside is the opposite of what you do. So right here, if I'm multiplying by 4, really I'm going to divide by 4 or multiply by 1/4. So I'm going to have 1/4 of x. That's what I'm going to do in order to get that period to change. So if I do 1/4 of x, so I have 1/4 times 0, that's 0. Well, what is 1/4 of pi over 2? So pi over 2 times 1/4. Well, that's going to get me pi, because if you're doing this, you're going to go straight across. It's going to be pi over 8. So that's what I got here, pi over 8. Then I'm going to do pi. Well, what is 1/4 of pi? Well, that's pi over 4. I have 3 pi over 2 times 1/4. 3 pi over 2 times 1/4. Again, multiplying fractions, you just go straight across. 3 pi times 1 is 3 pi. 2 times 4 is 8. So this is 3 pi over 8. And then here I've got 2 pi right here. So then I'm going to take that 2 pi and multiply that by 1/4. 2 pi times 1 is still 2 pi. This is technically a 1, so I have 1 times 4, that's a 4. Oh, well, 2 pi over 4, that's just going to reduce down and get me pi over 2. And so that's what this is. If you notice, we said that the period was pi over 2. That's how long it would take before it would repeat. We start at 0, we end at pi over 2. That works out quite nicely. One other way that you could do that, and this only really works if we're starting at 0, is I'm counting by my fractions. I went 1/8, 2/8, 3/8, 4/8. That's the other way that you can do it, doing this way. But again, that only works if that initial value here is a 0, because then it's just going up by an equal amount. So let's go ahead and graph this. So I'm going to go ahead and label my x-axis. I've got my new x values are going to be these. It's not going to be 0, pi over 2, pi, 3 pi over 2, and 2 pi anymore. We have shrunk that entire graph down. Instead of going from 0 to 2 pi before it starts to repeat, we've made it from 0 to pi over 2. So let's do that. So this is going to be pi over 8, pi over 4, 3 pi over 8, and pi over 2. So then we can go ahead and plot all of the points. We are no longer going to use these x-values. We just made that clear by labeling the x-axis this way. So we're going to use these x-values and these y-values. So at 0, we're at 0. And at pi over 8, we're up at 1. At pi over 4, we are at 0. And at 3 pi over 8, we're at -1. And at pi over 2, we're back up at 0. So I get this graph. All right, now our period of this. Well, we already established that. That's pi over 2. Okay. My midline. Well, we have not shifted the graph up or down. There's nothing added or subtracted outside of this. So my midline is just y equals 0. It's whatever the x-axis is. Amplitude, that is the distance from the midline to the maximum, or half the distance from the maximum to the minimum. So that would be 1. Okay. One thing that I do just want to kind of show you is I want to show you what the graph would look like with sine of x compared to sine of 4x. So let's take a look at that. It would look like if I had a graph of both of these kind of on top of each other. So you can see right here, the red graph that I've got right here, so this red curve, that's sine, right? And that's just y equals sine x. That's our standard y equals sine x, where it just goes from 0 to 2 pi and it takes that whole time to repeat. But you can see that now I've got 0 to pi over 2 before it repeats again. And then it's going to repeat again, going to go, and it's going to take another pi over 2 to repeat. And then it's going to go and do another pi over 2 and then repeat. And then it's going to go another pi over 2 before it repeats. So you can see I cut my period down in 4 pieces. I shrunk it 1/4 of it. And so that's why the graph itself is then horizontally compressed by a factor of 1/4. That's exactly what happened. Okay. All right. So now let's go ahead and look at this next one. So I have y equals, or f of x equals cosine of 1/2 x. All right. So let's do the same thing that we just did before, where I'm going to go, all right, so I got to make a table. X, I've got y. And again, the standard, if it was just cosine x, it would be 0, pi over 2, pi, 3 pi over 2, and 2 pi. And then cosine of those values would get me 1, 0, -1, 0, 1. Okay, so that would be cosine x, but I have cosine 1/2 x. Now, one thing that I want to kind of point out to you, if you notice right here, I just mentioned it just a second ago. This 4 right here, it reduced the period from 2 pi to pi over 2. It shrunk my period by 1/4. Okay? Or yeah, it's 1/4 of what it was. So now what I've got right here, I've got this 1/2 x. So this was 4x and I shrunk it by 1/4. This is 1/2 x, so I'm actually going to stretch it by 2. So remember, I've said it before and I will continue saying it over and over again. What is on the inside is the opposite of what you expect. Or I shouldn't say what you expect, but what you see. It's the opposite of what you see. So instead of multiplying by 4, we divide it by 4. Instead of multiplying by 1/2, we're going to divide by 1/2, or that's the same thing as multiplying by 2. So it's the reciprocal. So, and again, on the inside of the function here, it's going to change my x value. So let's change those x values. So I'm going to go ahead and take these, and I'm going to go, I got 1/2. Oh, sorry, I just wrote it because it says 1/2, and I even said it multiple times. 2 times x. So I'm going to take all these x values, multiply them by 2. So 0 times 2 is still 0, though. Pi over 2 times 2 is just going to get me pi. Pi times 2 is 2 pi. 3 pi over 2 is going to get me 6 pi over 2, which is 3 pi. 2 pi times 2 is 4 pi. So if you notice, I go 0 pi, 2 pi, 3 pi, 4 pi. That's nice and easy. I got rid of all the fractions. All right, so now I'm going to just go ahead and label the x-axis. And that's going to go 0. Why did I put 0 there? Come on. It's pi, 2 pi, 3 pi, and 4 pi. Okay, so those are going to be the values for my x-axis, because again, I don't need to label the 0, it's right here. And then I'm going to go up to 1 and down to -1. So the graph itself, again, I'm not graphing these. So I'm going to go 0 to 1, and at pi, I'm at 0. At 2 pi, we're at -1. At 3 pi, we're back up at 0, and 4 pi, we're up at 1. So I've got that. Okay, so what is my period? Well, that's 2 pi over b. So 2 pi over 1/2. 2 pi divided by 1/2. Keep, change, flip. We have a tendency to write it like this and then go, what the heck? I don't know how to do that. So again, 2 pi divided by 1/2, then we'll see it and go 2 pi times 2, and that gets me 4 pi. Which, again, because I've not shifted right or left at all, this 4 pi should match what I have right here. If I've gone left or right, that would no longer happen. All right, so my period here is 4 pi. My midline, y equals 0. My amplitude, there's no a value here. There's nothing that's changed, so it's just 1. I mean, there's no a value there, but it is a 1 right there, right? And that matches whatever my amplitude is. Okay. All right, so now this last one. If you notice this one right here, a good culmination problem here, I've got an A, a B, and a K. I've got all three things going on that we've talked about. So this 2 right here, what is that going to do? Well, that's going to vertically stretch my graph by a factor of 2. So it's going to make it taller by 2. So instead of going between -1 and 1, it's now going to go between -2 and 2. This 3 right here, it's reducing my period by a factor of 1/3. So my period's no longer going to be 2 pi. I'm going to shrink it by 1/3 of that. So it will now be 2 pi over 3. This -1 right here is that k value. That's that vertical shift. So it is moving my graph down 1. So let's go ahead and apply this information and create a little table to make ourselves, or make life a little bit easier. All right, so we've got x and y. And so we're doing cosine, and I'm going to keep it as our original 0, pi over 2, pi, 3 pi over 2, and 2 pi. And for cosine at 0 goes 1, 0, -1, 0, 1. Now I'm going to apply those transformations. So the 2 and the -1, those change the y value. This 3 right here is going to change the x value. So I've got a couple transformations going on here. So let's go ahead and write this out a little bit. So I'm going to go ahead and change the y. You can do it in 2 steps if you want to, or you can do it in 1 step. So I could go ahead and say, okay, this 2 is going to multiply by the y, and this -1 is going to subtract the y. So I'm going to go 2y minus 1. You can do that, or you can do 2 times y, then subtract the 1 from all that. I don't personally like taking multiple steps. Again, work smarter, not harder. So 2 times 1 is 2. 2 minus 1 is 1. Okay, that's interesting. All right, 2 times 0 is 0. 0 minus 1 is -1. Oh, okay, so we've changed it a little bit. Then -1. 2 times -1 is -2. -2 minus 1 is going to get me -3. So you can see already this has a lot of changes in it from what I already had here. While these are the same ones, this 0's changed, this -1's changed. And I can see that that's just from me taking this and I've stretched it, made it taller by 2, and I've shifted it down 1. So again, this 0 is going to be -1 and this 1 is 1. All right, so let's see what that's going to do to the x values when I go ahead and apply the changes that we had on those. So the changes to the x values that I've got right here. Changed with the x value is going to be, I'm going to take all of them and I'm going to divide by 3. So I have x over 3, or I could just multiply by 1/3. However you want to look at it. 1/3 of x. Same exact thing. So 0 divided by 3 is still 0. Pi over 2 divided by 3, or pi over 2 times 1/3, gets me pi over 6. Pi times 1/3 is pi over 3. 3 pi over 2 times 1/3. 3 pi over 2 times 1/3. Again, go straight across. That would give me 3 pi over 6. 3 pi over 6 reduces. That gives me pi over 2. And then 2 pi. 2 pi over 3, because it's 2 pi times 1/3, or 2 pi divided by 3. So 2 pi over 3. And that matches exactly what I said earlier. If you paid attention, if you recall, I said to find our period, it's 2 pi divided by b, and b here is 3. My period is 2 pi over 3, and I go from 0 to 2 pi over 3. So that works perfectly. So let's go ahead and label this x-axis to match the values that I just found. So it's going to be pi over 6, pi over 3, pi over 2, and 2 pi over 3. So at 0, my output value is 1. Oh, sorry, I didn't label my y-axis. I need to do that. So this would be 1. I got 0 here, and I'm going to go -1, -2, and -3. So now, here at 0, we're up at 1. Pi over 6, we're at -1. Pi over 3, I'm at -3. Pi over 2, I'm back at -1. And 2 pi over 3, I'm back up at 1. So I have this little shape right here. All right, so I've already answered some of these questions, but I'll go ahead and write them down. The period, it's 2 pi over b, which is 3. Midline. Midline is whatever that value there is. Y equals -1. And I can see it right here. This is halfway in between my maximum and minimum. My maximum is 1. That's a distance of 2 from -1 to 1. And my minimum is at -3. That's, again, a distance of 2 from that -1 to -3. So that's halfway in between right there. My amplitude, well, that's that distance that I just mentioned. The distance from the midline to the maximum was 2. So that's my amplitude. It also is the exact same number as whatever my A is. My A is 2. Remember, the amplitude is the absolute value of whatever is being multiplied by the trig function out front. And that's what I've got. So we've done amplitude, period change, and vertical shift. The only one last thing that we have to do is what's called phase shift. And that's going to be this H value here. And that's going to be that horizontal shift right or left, depending upon whether it's added or subtracted in there. And we'll talk about that one on our next video. Okay? Let me know if you have any questions. If you're struggling with anything, I want to make sure that you're okay. So be sure and reach out if you're struggling.